More than 20 years ago, back in 1999, we discovered an interesting diamond-shaped space rock. It was an asteroid called Ryugu. Ryugu. Its name is the Japanese term for Dragon Palace. There's a Japanese folktale behind that name. Basically, it's about a magical palace hidden deep underwater. In this story, there's a fisherman who visits the castle traveling on the back of a turtle. He returns back to the surface with a mysterious box. About 2 years ago, a similar thing happened in reality when the Japanese spacecraft, Hayabusa, visited Ryugu and came back with mysterious samples it picked up there. And the fairy tale doesn't just stop there. There are so many craters and rocks on Ryugu, so it probably had quite a rough past. And the craters all share a theme. They're named after something from the world of fairy tales. For example, the name of the princess who lived in this magical Ryugu castle, together with her dad, a dragon deity. Some got names after the fisherman who saved a turtle, and the turtle itself, of course. But back to the science now. So, this spacecraft took a sample from the surface of Ryugu, got back to Earth, and teams of researchers discovered something really cool. This asteroid is even older than our solar system. The spacecraft took the sample to help researchers to understand the origins of our solar system better. But this is not the first time scientists came across such ancient grains. They previously found them in multiple meteorites. Meteorites are generally space rocks that survive the fall through the atmosphere to land on Earth. They're usually rich in carbon, just like the asteroid Ryugu. But the material on Ryugu is even more specific, and something you can't stumble upon on our planet. Silicon carbide, a combination of pure silicon and pure carbon. The material Ryugu is made of is so unusual it even tells us the asteroid was formed in the outer solar system. It's one of the 3 asteroids, Itokawa, Bennu, and Ryugu, that are orbiting the Sun, but are moving relatively close to Earth. Each of them is just a loose pile of rubble, and their collective gravity is something that holds them together. They probably formed after their parent bodies collided and shattered into smaller pieces. Ryugu's individual rocks are probably 4.6 billion years old or even more, so it's most likely made up of material from its parent body, but some theories claim its surface could be 158 million years old. Ryugu sneaked into the inner part of our solar system, so we got a better chance to study it a little bit. It's circling around the Sun somewhere between our home planet and Mars. It crosses Earth's orbit from time to time, which is why it ended up in a category of potentially dangerous things for us, even though it's peaceful at the moment and it really doesn't harm us in any way. It's one of the darkest space bodies in our solar system, and it's surprisingly dry. Strange, its parent body probably consists of lots of water ice. Maybe Ryugu is dry because it has flown too close to the Sun sometimes in the past. That heated up its surface and dried it out, or some of its radioactive materials heated the asteroid and removed most of its water. How do we even know how old our solar system is? Once upon a time, which is billions of years ago, in some faraway, almost forgotten corner of the Milky Way, there was a molecular cloud. It fell apart and collapsed like many others across the universe did. That's how new stars form. This one formed new stars too, and one of them was a little bit isolated from the others. It collected material around it and turned it into something we call a protoplanetary disk. That's a disk of gas and dust that rotates and goes around the core of what will later become a solar system. That disk can develop into celestial bodies too, like asteroids and planets. But this disk formed the central star we today know as our Sun, 8 planets, and the rest of the objects that make our solar system. It's about 4.6 billion years old. All stars come from this pretty cool thing called a pre-solar nebula. It's once again a cloud of dust and gas that pulls material in. Later, a star forms out of it. A big outer region that surrounds a nebula is cold. A pre-solar nebula creates a protostar. It's a young star that is still not on its own, but needs to gather mass from its parent cloud. Then the star becomes independent. The material from the outer cold region then starts forming bigger clumps. As time goes by, these large clumps grow and fall in. They move around, interact with each other, and sometimes even merge or eject one another. After hundreds of thousands to even millions of years, once there's a star, the planets start forming. There were probably many objects that are gone by now, but our solar system doesn't look very different from what it was back then when it formed. Some things may have been different though. We have 4 gas giants now: Jupiter, Saturn, Uranus, and Neptune. Maybe there might have been a 5th one too. It's possible our 4 gas giants were closer to the Sun, but they migrated outwards. And what was between Venus and Mars? One theory says Theia, a smaller Mars-sized world that later, bam, collided with Earth and we got the Moon. Checking the materials of these objects, scientists have found out many interesting things when they study all kinds of minerals, rocks, and solid bodies. The composition of different elements tells them about how old some object is. They have studied meteorites that have landed on our planet. They assumed these meteorites and the Earth are part of the same system, so they calculated their potential age and got about 4.34 billion years. Rocks from the Moon haven't gone through the same processes as Earth rocks, and they're younger by a couple of million years. And the Sun, the central star of our solar system, could be a bit older. Maybe tens of millions of years older than the oldest rocks. That's how formation in most cases goes, remember? Stars first, then planets and other solid objects next. So yes, it could be close to 4.6 billion years old. Jupiter's satellite Callisto is, as far as we know, the oldest moon both in our solar system and the universe. It's not that glamorous, just a rocky world with ice covering its surface and many craters. These craters tell us that many random flying objects have been hitting it over the past 4 billion years. That's how long we believe it's been around. Callisto and the rest of the moons around Jupiter have probably been born out of debris that was left after Jupiter formed. This all seems so old, but universe is 13.7 billion years old, so imagine how many things out there are even older than our solar system. But now, scientists have confirmed they have found one of the oldest, but also most distant objects we've ever known in the universe. It's a galaxy, Geo9 83808, 12.8 billion light-years away from us. It started forming within the first billion years of the universe, which also means it was that long after the Big Bang started everything. During the first 400 million years after the Big Bang, it was most likely way too hot for anything to form. So first galaxies, black holes, and stars started forming maybe within the first 500 million to 1 billion years. So this old galaxy could be one of the first things that ever appeared in the universe, and we get to see it. It's hard to observe it though. Scientists use a telescope to explore it, but the picture's still very blurry. It's hard to see such objects because of all those thick, gigantic clouds of dust that surround them. The Hubble Space Telescope is usually best to view distant galaxies, but there's another telescope, LMT, with a better position to look at such objects, and we can't wait for it to be fully operational to see what else it'll discover. There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahansa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahansa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes, and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous study of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy, and according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't be actually tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e., absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe, and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too, and these blocks are called electrons and positrons. But what holds all these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before, and according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simple. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe, and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law V. From only one fundamental universal constant, all the constants, considered universal in contemporary physics, are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different, and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes, and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe, according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it has had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem in the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the most interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We do know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers are not sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager. I also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light though. It is like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps showed that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helped scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happened in galaxies producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. They are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense, hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So some stars become black holes. Since light itself cannot escape their pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It has also noticed a strong connection between the sizes of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than the Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Before Hubble, we didn't really know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the Sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our Sun emits most of its energy at a wavelength that's close to green, but because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the Sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the Sun isn't on fire for real. It's a big ball of gas made mostly of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the Sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans. A spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So technically you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope. You won't turn into a popsicle right away. It's going to take a bit longer than that, because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then, after just 2 minutes, it's curtains for the rest of your organs. So in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out. So all those epic space battles and galactic explosions would be completely silent. Yet, there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free falling around the planet. And let's be real, Hollywood's version of space travel is not the fact. Sure, orbits are a thing, but different altitudes mean different speeds, so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added up some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lee. It's zooming through space at a speed of 140 mph, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket because that would be one astronomical fine. Without the sun, planets would be pretty chilly. We're talking temperatures as low as 455 Ross Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things, like the planet's size and reflectivity, also come into play. So, Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe, and there's still so much we have yet to discover. Who knows? Maybe one day we will really discover little green people out there, or maybe we'll find something even more incredible. Until then, we'll just have to keep dreaming and exploring. There you got 14 things on our list. Do you have any other space myths to debunk? It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? C, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hanson, 1996, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam! Everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter Theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, and it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield, so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? So the idea of panspermia is that life can travel through space naturally, like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, travel through space, and land on another planet, but turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off one planet, flying through space, and then landing on another planet. So scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection. Like, they could be space superheroes with a dash of sunscreen. And if they're shielded by 2 meters of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets, but now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic Lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it is unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms, or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, this theory might sound a little out there, but some scientists actually take it seriously. They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere, or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water heated by the Earth's core comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using the chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean, the hydrothermal vent. Theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here.